Alright, we're looking at Pythagoras in 3 dimensions. What will usually be the problem with a 3-dimensional shape in Pythagoras is we'll need to find a length that's inside the shape, and we will often need to find more than one length in order to get this. So here I've got a cube of 5 centimeters square, or 5 centimeters on each side, and they want me to find the distance from the bottom front corner to the top back. So the method that you're going to have to use for all of these is finding a right-angled triangle that's got that length in it. Now, since all the sides are at right angles, you can see that this side AG forms a right-angled triangle with this side AH. Now, that's okay, but I've only got this length here, GH. I don't have this side AH, but there's another right-angled triangle, ADH, which would allow me to find this. So your usual procedure is going to be finding 2 separate sides. Work out where the triangle is that you need, and work out how to get the lengths of that triangle. So we're going to start with triangle ADH, and it's a really good idea to redraw your triangles. So each side is 5 centimeters, and this is side C, which we want to find, or of course I could label this ADH. And I like to stay nice and organized and say, here I'm finding AH, because that lets me know and lets the person marking my test know what I'm doing. So this is just simple Pythagoras. We write our formula, substitute in our values. So c squared equals 25 plus 25, which is 50. C equals the square root of 50. And if you like, if you're comfortable working with surds, you can, that is square roots, so zooming in there a little for you, you can leave it at that point. Or of course, you are absolutely welcome to find the square root of 50, and C equals 7.0711, keeping lots of decimal places, and we're in centimeters. Now the reason I'm keeping more decimal places is because I'm going to have to use that in my next calculation. But you are absolutely welcome to leave C equals the square root of 50 as your answer for this first step, because that's quite useful when you come to finding the actual thing that you want. So now I've got this length along here. I'm going to redraw this triangle. It's the one I actually care about. And this is AGH. It's a right-angled triangle there. And I just found AH. So this is the square root of 50, or of course I could write in this. GH is 5, and this is what I'm after here. So my next step is finding AG, which is the side I really wanted. Again, Pythagoras' theorem, c squared equals a squared plus b squared. Substitute in your values. Now I've got 5 squared plus the square root of 50 squared. Now if you square the square root of 50, let's just check it. In brackets, the square root of 50 squared, whoops, sorry, I want to close that bracket and square that, sorry, I'm missing a bracket in there, which has been quite annoying. Square root of 50, hop out of that, squared is 50. So that makes sense. Square root of 50, square that, I should get the number that multiplies together to give 50. So if I square it, I'll get 50. So you can just say, well, look, that is 5 squared is 25 plus 50. You don't need to use your calculator. You know that the square root of 50 squared is just 50. C squared is 75. C is the square root of 75. So C is 8.66. And that side was AG that we're looking for, so therefore AG equals 8.66, and we're in centimetres. So you do need to be quite careful with your working, showing step by step. It's a good idea to redraw each triangle so you really know what you're doing and stay on top of which side it is that you're looking for. A type of question that we often get is involving a cone or a square-based pyramid, especially if we're finding the volume of this shape. What I'd need is the height from the center of the base up to the point at the top. I'll draw that line in. And again, that's something that you can't measure with a tape measure or a ruler when you've got that shape. So Pythagoras is needed to work it out. Again, what you need to do is look for a triangle where you have the side values. So we've got this side here, AE, which is 26. So I could absolutely turn this into a right-angled triangle by coming out to there. There's often a couple of different choices you can make. So I'd need this side AF, and so I'd have to look for a right-angled triangle that included that, where I had two sides. Technically I could go out here and make this right angle, but that would get very complicated. Probably better off going straight across and making this my first right-angled triangle, ABC. So I'm going to have to find AC, and then half of that is going to be AF, because this is a square, its diagonals bisect, cut each other in half. So finding AC, draw my triangle, ABC, that's a right angle, these are both 25. So I've got two lots of 25 squared. So just multiply that by 2 there because there's two of them. C squared is 1250. So remembering, of course, you can leave C as the square root of 1250, and that will be side AC. You can keep calling these the actual letters. I could say this is AC squared, AC squared. So AC, it's a good idea to pop those in brackets so you're saying it's the side AC squared. I'm not very fond of it, but it is quite correct. You're quite able to do that. So remembering, of course, you can leave this first side as a square root, or there's no problem with evaluating that. 35.3553. Keep about 4 decimal places, and that's in centimetres. So then we've found that. I want to find this side here, which is what they've asked for. Again, redraw the triangle that I'm interested in, and it's only into the centre here. So this is triangle AEF. I've got 26 centimetres there, and AF is half of AC. So I'd probably put a little bit of information here saying AF equals AC over 2. So just making sure that I've divided that by 2, that I've really got an accurate sense of what I'm doing with my working. So I've shown how I got AF, and this is my side that I'm after here. Pythagoras' theorem, b squared equals c squared minus a squared, because of course I'm finding a short side. And doing our working. Might as well square that one to start with. So I just had that up, so I thought, look, I'll square that since it's there. It saves me typing it in. 26 squared is 676. So b squared, I'm taking that and subtracting 312.5. b squared is 363.5. b is the square root of that. .07 to 2 decimal places, and we are in centimeters. So your trick is really look for the right angled triangles. If they didn't give you a diagram, if they explained or described the shape, do draw one. It's very important. And be very careful about working out what you're finding, showing your working, and then using that length in your next working.